First of all, when we're solving systems of equations, um, we're we're actually just solving linear equations at this point. And when I say linear equations, we have two of them here. Linear means lines, right? So here's a line, and then this is going to be a line. So if you think about solutions to a line, it's the points. And when I have two lines, there's only three scenarios that are going to make me have a solution, okay? Now, the lines can intersect. So if I have intersecting lines, they're going to intersect at exactly one point. So that's my first solution scenario. I can have exactly one solution. Okay, and that solution, notice, that solution is a point. So I have to give my answer as a point. Parenthesis, comma, parenthesis. Then I'm going to have an X and a Y value. Okay. Now, there's a second way. If they intersect on this one, I can have where two lines don't intersect. And if they don't intersect, they're going to be, back to your geometry days, parallel lines. So I'm going to have two lines that don't intersect at all. So that means that there's no point in common. So there's no solution. And I always abbreviate solutions as SOLM. You can write it out or use your own abbreviation. I don't care. And remember, that point, like in scenario number one, that point has to work in both equations at the same time. That's why there's no solution here. There's no point that'll work for both equations at the same time. And the third scenario, well, if they intersect at one point, don't intersect, what if they always intersect? And what does that mean? Well, I can have a line here. And then I can put another line right on top of that. So now I have every single point that intersects. So I have infinitely many solutions. Infinitely many solutions. And you can abbreviate like that. I don't mind that. So you're going to have to give it to me, the answer, in either as an ordered pair. You're going to have to write no solution or infinitely many solutions. Now, these are pictures of the graphs. And you're probably saying to yourself, well, what if I don't always have graphs of lines? What if we do it algebraically? Well, algebraically, it's going to look like this. When you solve these equations, you're going to get x equals a number or y. And then you solve for the other variable. In this case, solve for y. And that's why we did isolating variables, that section about solving for different variables. Now, if I have where they don't intersect and I'm doing it algebraically, I don't have a graph and a picture, I'm going to end up with something, an untrue statement. something like, oh, 2 equals 3, or 0 equals 9, something like that, something that's not true, then I'm going to have no solution, because obviously there is no solution when I get something like that. And the last one, if I have infinitely many solutions, it's where I have a number equal itself. So there's no variables involved when I solve it algebraically. Here I have a variable involved. And we'll see if we can get, if I pick the right ones. Okay. All right, number one. You guys remember how to write lines? And I think we did this too, review of graphing lines. We have to make sure that it's in y equals mx plus b, because that's the easiest way to graph a line. So let's look at the top one, and it is in y equals mx plus b, same at the bottom one. So for the top one, always start with your y-intercept. So b equals -2. My slope equals 1/2. It's the coefficient of x. Or, depending on how it fits on the graph, I may want to use -1 over -2. I'm going to go ahead and graph that line. So I'm at -2. And this time I'm going to go up. I'm going to use the positive. I'm going to go up 1 to the right 2. Up 1 to the right 2. I could use the -1. Down 1 to the left 2. Down 1 to the left 2. The more points you put on this, the more accurate it is. Because we know that graphs are not always the easiest thing to read. That's why they're not always as accurate as solving it algebraically. So there's my line. Now I got to do the same thing for the second one. So my b here is 3. My slope is -2. I'm going to put it over 1. Or I can put the negative sign with 1. So I start at 3. And actually, I'm going to use the first one. Down 2 to the right 1. I'm going to keep going until I know these are going to intersect, till I get to that point. Because I know exactly where they intersect now. Don't leave your answer without the ordered pair. The answer is 2, comma, -1. Okay? This one gets kind of, number 4 gets kind of long and complicated. Like I said, I did this on the video. Make sure you get in the y equals mx plus b form first. I think I did all of these on the video. So for this one, you would have to solve, I'll set it up for you, one of them. So x plus 2y equal 4. I would have to subtract x. I get 2y equals -x plus 4. Then I have to divide every term by that 2. So I end up having y equals, now there's a 1 there. I get -1/2. I'm going to pull that x out because it's in the numerator. +4 divided by 2 is +2. And then graph this line. And you're going to have to do the same thing to this one. So make sure, if you are a little rusty with this, watch the video. Okay? Work through the problem. Now we're going to do it algebraically. You guys remember doing this by substitution? Come on, focus. There we go. Now this one's easy because they both equal y. I just set these equal to each other. So I'm going to do a different one here. This one I screwed up on first block, so let me do this one again. Okay, number 8. I have to have, the first thing you do when you use substitution is you have to isolate a variable. And it doesn't matter which one you use. If you want to isolate the x's, fine. I'm going to isolate that y on this particular one. So I'm going to take this equation, negative 6x plus 3y equals negative 9, and I'm going to isolate that y. Now you can do the x, it doesn't matter. I just decided to do the y. So I'm going to add 6x to both sides. So that ends up to 0. Bring down my 3y. Do not, guys, do not combine these. 6x minus 9. Notice I got a 3 in front of my y, so I have to divide every term by 3. I get y equals 6 divided by 3 is 2. I have my x. Negative 9 divided by 3 is negative 3. So now I have my y isolated in this one. Here's where it gets a little tricky. This is what y equals, right? I'm going to substitute it in for this y in this other equation. Okay, so I have 7x minus 5. Now for the y, I'm going to substitute in 2x minus 3. And then my equals 21. Now I solve for x. 7x, I have to distribute minus 5 to 2x and to the negative 3. So negative 5 times 2x, negative 10x, negative 5 times negative 3, so positive 15 equals 21. Solve for x. Combine my like terms. Negative 3x plus 15 equals 21. Solve for x. Minus 15 minus 15. I have my negative 3x equals 6. Divide by negative 3. And I get x equals negative 2. Now, you're not done. All right? Because this is a scenario where I have intersecting lines, I must have an ordered pair for my answer. I know my x is negative 2. I have to find y. So I'm going to go back and pick one of these. Doesn't matter which one. I'm going to pick, well, let's see. I'm going to pick the bottom one just to be different. 7, my x minus 5y equals 21. My x is negative 2. And now I have to solve for y. So I have negative 14 minus 5y equals 21. I'm going to add 14 to both sides. I get negative 5y equals 35 divided by -5, and y equals -7. So these things take a long time. Be patient. So that's substitution, and that was actually the hardest one. Elimination is the last one. Elimination is when you add the equations together, you're eliminating at least one of the variables. Okay. So let's take a look at number 11. If I just add these together, okay, -35 plus -7x, they're not going to be eliminated. Same with the y's. So what I'm going to do is I'm going to make this y a -5y so that when we add those, the y's will eliminate. So to do that, I have a +5 up here. I want that a -5. So I'm going to multiply the entire equation by -5. So I get -5 times -7x is 35x. -5 times +y is -5y. -5 times +y is -25. I'm just going to bring down the other equation. It's -35x plus 5y. Now these will eliminate. Equals 21. Add these two equations together. And it just so happens both of these add up to 0. -25 plus 21 is -4. And I get 0 equals -4. This is an untrue statement. So what I have here is parallel lines. There's no solution. That's the last one I'm going to do for you. And again, I believe I did most of them on that other video. It's a pretty long video. It's like half hour. So if you really need more practice at this, more explanation, go ahead and look at that video.